Right. We are going to be talking about finding the input and output values of a function in the three representations. So using a formula, a table, and a graph. But first, we are going to, so if we have an equation, we're going to talk about evaluating and solving a function. Okay. So first, evaluate. So here it explains, given the formula for a function, evaluate. Okay, so here's what we do. Step 1, replace the input variable in the formula with the value provided. Step 2, calculate the result. Okay, so let's do this example. Evaluate this function, f of x equals x squared plus 3x minus 4. Hopefully this kind of function looks familiar. You're already thinking, that looks like it's going to be a parabola if we graphed it. But we're getting ahead of ourselves. So let's go here and solve and evaluate this function. So our function, we have f of x equals x squared plus 3x minus 4. Okay, there's our function, and we want to evaluate it first at 2, at x equals 2. All right, so everywhere that there's an x in this function, we're going to say f of 2. Everywhere there's an x, we replace it with a 2. So we're going to get 2 squared plus 3 times 2 minus 4. Right? And now we just have to use our orders of operations and evaluate this. It's been a long time since we've done math, but we can do this. 2 squared is 4. 3 times 2 is 6 minus 4. So 4 plus 6 minus 4 is going to equal 6. Great. We had a function. We put in a number. Out came a different number. All right, for part B, they want us to find what if to evaluate f at A. Okay, well, this is weird. It's a letter, so we're going to find f of A. So we're going to do just what we did before. Everywhere there's an x in this equation, we're going to replace it with whatever is in these parentheses. So everywhere there's an x, I'm going to replace it with a. So I have a squared plus 3a minus 4. And that's all I can do, right? It's a letter. We don't know what the value is. That's what that function is, the value of that function at a. All right, let's see. In part C, they wanted us to find it when at the point a plus h. This is getting weirder. All right, so we want to evaluate it at a plus h. Okay, now we've got two letters added together. We're going to plug those in. We're going to look at our original function, and everywhere there's an x, we're going to plug in everything that's inside these parentheses. So we'll have a plus h squared plus 3 times a plus h minus 4. Okay. Can we simplify this at all? Yeah, we can, right? We could multiply this out. We could FOIL this. We could distribute this 3. Let's do it. Let's see. A plus h squared. So it's going to be a plus h times a plus h. And then I can distribute, so times 3 times a plus h minus 4. Right? So I've got two binomials multiplied together. You can FOIL if that's what an acronym that helps you. You can do first, outer, inner, last. However works for you to multiply binomials. Hopefully that's something that looks familiar. A times a is going to be a squared plus ah plus ah plus h squared plus 3a plus 3h minus 4. And I guess I could have these two like terms, ah plus ah. So I'll add those together and get 2ah plus h squared plus 3a plus 3h minus 4. And that still looks pretty messy, but we're going to leave it like that. Okay. And the last thing they wanted us to evaluate was f of a plus h minus f of a all over h. This looks like a little bit of a random thing for them to ask us to evaluate. But I'll tell you what, this is actually an important equation. And if you want to know why, you need to take calculus next year. Okay? This is called the difference quotient. And we'll leave it at that. But luckily, we've already evaluated this, and we've already evaluated that. Right? F of a plus h, we know, is this whole long thing. A squared plus 2ah plus h squared plus 3a plus 3h minus 4. Right? That's f of a plus h. F of a is this thing. So minus a squared plus 3a minus 4. Anytime there's a minus sign, we have to be very careful, right? They try to mess us up. All divided by h. This looks like a mess. Don't get overwhelmed by this, okay? This is just good practice. Get us a little bit into the math mode here. Let's see, we've got an a. Maybe I'll just distribute that minus sign so I don't get confused. So we'll have a minus a squared minus 3a plus 4, right? I distribute this minus sign to each of these terms, divided by h. All right, so let's see. I've got an a squared minus a squared. Let's see if I can combine some terms. That's going to go away. I have a plus 3a and a minus 3a, so that goes away. I have a minus 4 and a plus 4. This is nice. Everything's canceling out. So I'm going to get a 2ah plus h squared minus 3h all over h. That is interesting. It looks like I have 3 terms up here. Each of them have an h in them. I can factor an h out, right? So let's see. We could factor an h out here, and I get a 2a plus h minus 3 all over h. Right? I factor an h out of each of these terms. The h's cancel. Dun, da, 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 and I'm just left with 2a plus h minus 3. That is kind of amazing that this big mess simplified down to that. There's actually good reasons. Like I said, this is a special equation called a difference quotient. If you take calculus, you'll understand how special it is. But for now, here, parts A, B, and C are the important parts for you to focus on. Okay, if you could do parts A, B, and C, I wouldn't worry so much about part D. All right, so there we were evaluating a function at a number, a letter, 2 letters added together, and then finding a difference quotient. Let's go back to this for just a minute. Let's do another example. Given the function h of p equals p squared plus 2p, evaluate h of 4. All right, pause the video for just a minute, find the answer, and come back. And we'll work through it together. All right, so here, let's see, they gave us the function h of p equals p squared plus 2p. And they want us to solve for, wrong one. Nope, they want us to find h of 4. Okay, h of 4, not so bad. Everywhere there's a p, right? Here's our input variable p. Everywhere there's a p, we'll plug in a 4. So we have 4 squared plus 2 times 4. Let's see, that's going to be 16 plus 8 is 24. Whew, that's my answer. That was not bad, right? So don't get freaked out about the previous example. This is the kind of thing you got to be able to do. Not too tough. All right, so that was evaluating functions. Now we need to know how to solve functions. It's a different word, right? So here's an example. Given this function, the same function, here they asked us to evaluate it at a value. Here they want us to solve it. They say solve for h of p equals 3. So let's see, they want us to find where solve h of p equals 3. All right, so to solve this, here's our function, p squared plus 2p equals 3. All right, time to remember our Algebra 2 skills. How do we solve this? Do we factor p out? It's tempting to do that. Many people do, but no. This is a quadratic, right? And to solve a quadratic, we need it equal to 0. So we need to move the 3 over. P squared plus 2p minus 3 equals 0. Aha. Now we've got a quadratic. We've got tools to solve quadratics, right? We can factor. We can use the quadratic equation. We're going to review all of this stuff, right? For this one, we can factor this, right? We're looking for things that multiply together to be -3 and add together to be 2. Well, so -3 doesn't have that many factors. How about 3 and -1, right? Can we factor this as p plus 3, p minus 1 equals 0? Let's see, does that work? P times p is p squared minus p plus 3p minus 3. Yes, if we multiply this back out, we would get this equation above it, right? If that doesn't look familiar, we'll talk about some resources you can do to practice factoring, okay? And now what do? We've got 2 factors equal to 0. We use the zero product property, right? We said each of the factors, p plus 3 equals 0, and p minus 1 equals 0. So each of the factors equal to 0 separately, and we solve. And we say, okay, p equals minus 3, and p equals 1. Okay? Hopefully that looks kind of familiar. I'm going through a little bit fast because you can always pause and rewind and rewatch what I'm doing and kind of go step by step. Okay, so you can go as slow as you need to through these. All right, so, oops. This is a graph of that function. Okay, so remember, it looked kind of like it was a quadratic, and we're remembering, quadratics are parabolas. So this is just an observation. This is what it looks like, right? That's what the graph of that function, h of p, looks like. And they asked us to solve it for when h of p equals 3. That's that dotted green line, right? If you look at the y-axis here, right, 3 goes right along that dotted line. And they asked us to solve it. So we set h of p equal to 3. And what did we find? We found the answers 1 and -3. And lo and behold, that is where this parabola crosses that line, h of p equals 3. Kind of cool. Okay, now we're going to talk about evaluating functions expressed in formulas. Okay, so here's the steps. Given a function in equation form, write its algebraic formula. So first, we solve the equation to isolate the output variable on one side of the equal sign. The other side is an expression that involves only the input variable. And then we use our usual algebraic methods for solving equations, such as adding or subtracting, multiplying or dividing, right? So let's do an example. Example 9 says, express that relationship as a function p equals f of n, if possible. All right, so let's go back to our paper. Our relationship is 2n plus 6p equals 12. And we want to write it as a function of n. Okay, so what that means is, first step, we want to put the output variable on one side. What's our output variable here? P. Okay, we want our output variable on one side and everything else on the other. So we're going to try to isolate P. That's our goal. All right, We want to isolate for p. How can we do that? Well, let's subtract 2n from both sides. So we'll have 6p equals 12 minus 2n. All right, now we've got this 6 to deal with. How can we isolate p? We want to divide everything by 6. Divide every term by 6. So we're going to have p equals, let's see, 12 divided by 6 is 2. And we could simplify this as 1/3 n. Right? That's what we mean in that example when it says to express this relationship as a function. Okay, we want to isolate the output variable. All right, what about example 10? Does this equation, x squared plus y squared equals 1, represent a function with x as an input and y as an output? If so, express it as a function. All right, well, let's see. We have x squared plus y squared equals 1. And they want us to have y be the output variable. Right? So that means we want to isolate y. We want everything else on the other side. So let's subtract x squared from both sides. We get y squared equals 1 minus x squared. Well, it's by itself now, but we need it just to say y. We can't have it be y squared. So how do we undo a square? We take the square root of both sides, right? So we get y equals the square root of 1 minus x squared. Is that the only answer? This is a trick one. It's actually plus or minus, right? When we take a square root, we get both roots. We get plus or minus, right? So this has two solutions. Y equals the square root of 1 minus x squared, and y equals minus the square root of 1 minus x squared. So if I give you an input value for a value of x, how many output values do I get? 2, right? What if I said, if x equals 0, what does y equal? Well, yeah, if x equals 0, what does y equal? Well, here, y would equal 1, and here, y would equal -1. Is that ringing any alarm bells? One input value gives you 2 output values. Is it a function? It is not. This is not a function. It's a relationship, but it's not a function. All right. So now we're going to talk about tables. Okay? If we talked about tables a little bit already, but if we have a function in tabular form, how do we evaluate and solve it? So first, evaluate g of 3. Well, let's see. Here it tells us how to do it. Given a function, identify specific output and input values. Right? First, find the given input in the row or input values. Identify the corresponding output value, of course, paired with that input value. Or we can go the other direction. That's what 3 and 4 says. So evaluate g of 3. Well, let's see. Our input value is 3, and our output value, g of 3, is 7. Okay. What about solving? This is the opposite direction. Okay. If we have a function, we want to solve it, we go the other way. We go to the output. If solve g of n equals 6, we go to the output. G of n equals 6. What's the input? 2. Okay. So if we're evaluating, we go to the input value and find the output. If we're solving, we go to the output and find the input. So just in your mind, evaluate g of 2. What is it? 6. Solve g of 8. There's two different input values that give that to you, 1 and 5. Is that a problem? No, that's fine, right? That's like when we solve the equation. You can, when you're solving something, you can have two different input values. So g of 8 has two different answers, 1 and 5. All right, so now let's talk about graphs. Finding function values from a graph. So here we've got a graph of a function, f of x. Looks like a quadratic, looks like a parabola, right? All right, so we're going to do the two things, evaluate and solve. If we evaluate f of 2, our input is 2, right? So we go along the x-axis. There's our input value, 2, and our output value is the y value of that point, right? So the output value is 1, right? So f of 2 is 1. How about solve f of x equals 4? We go the opposite way, right? We go up here to the y-axis. We say, okay, here's 4. What values? Where does this graph cross those lines? Cross that line of 4? Well, there's a point here and a point there. And the x values are -1 and 3, right? So if we're solving f of x equals 4, the two x values are -1 and 3. Okay, so to evaluate, we go along the x-axis and find the y value. To solve, we go along the y-axis and find the x values.